Okay, welcome back. Today is Tuesday, and make sure that before you start today's lesson, you have completed day 6, yesterday's lesson, which was only 2 questions. So today we're still going to be under sequences in series unit, and today we're going to be doing summation notation. So once again, if you see in your notes, what you're actually going to be doing every slide today in your notes. So every slide is going to have the little box at the top right to tell you to write it in your notes. Go ahead, pause the video, and copy this down so you can fill it in when you're ready. So a way to represent a series is using this Greek letter sigma to denote the sum. So anytime you see this letter that looks like an E, the Greek letter, I'm going to read it out loud as a sigma. So what you're going to do is you're going to see a sigma with a number at the top and a number at the bottom. The number at the top is the last term number, whereas the number at the bottom is the first term number. This equation on the right is going to be the formula that you use for the sequence. So right here, what we're going to do is we're going to find the sum of this series. So this is a series. We have to actually expand it. So what we're going to do is we're going to do 2 times n. We're going to start out when n is 1. So 2 times n when n is 1. Then we're going to add 2 times n again when n is 2. And we're just going to keep going up by 1 until we stop at the top number, the last term number. So 2 times 3 plus 2 times 4 plus 2 times 5. That would be our last one. Then you can just use your calculator, which that is what I did, and it gives us 30. So the answer to this sum right here is 30. Okay, we're going to have, I believe, 5 examples today. This is the first one. The directions are all going to say the same thing. Expand each series and evaluate. So what I like to do is I like to find what each term is individually, and then I add all of those sums up together. So we've got the equation 5k plus 2, and we are going to find out what this equals when k is 1, when k is 2, when k is 3, and when k is 4. We're going to stop at 4 because that's our top number. So we're going to do 5 times k plus 2 when k is 1, 5 times k plus 2 when k is 2, 5 times k plus 2 when k is 3, when k is 4, and that's the last one. So what I'm going to do now is write down what each one of these individually equals. So 5 times 1 is 5 plus 2 is 7. 5 times 2 is 10 plus 2 is 12. 5 times 3 is 15 plus 2 is 17. And then 5 times 4 is 20 plus 2 is 22. So here we have expanded our series. We're going to add them all up now because that's what it means to find the sum. So 7 plus 12 plus 17 plus 22 is equal to, I did it on a calculator, 58. So the answer to this sum is 58. Example 2. Same difference. You got an equation on the right. You have your beginning term number and your ending term number. So I'm going to find out what this equation equals when y is 1, when y is 2, when y is 3, when y is 4, and I'm going to stop when y is 5 because remember, at the top number is our last term number. So we have y squared plus y. So 1 squared plus 1, then 2 squared plus 2, 3 squared plus 3, 4 squared plus 4, and then 5 squared plus 5. 1 squared plus 1 is 2, 2 squared is 4, plus 2 is 6, 3 squared is 9, plus 3 is 12, 4 squared is 16, plus 4 is 20, 5 squared is 25, plus 5 is 30. So all I did here is I used this equation, y squared plus y, and I evaluate it for when y is 1, 2, 3, 4, and 5, starting at 1, ending at 5. Now what I have to do is add all of these up together. So 2 plus 6 plus 12 plus 20 plus 30 is equal to 70. All right, example 3. Notice that for example 3, I went right into using the calculator. I didn't even write anything down. Now, the reason why I did this is because I have some higher numbers here, so c cubed. I don't know what 6 cubed is in my head or 7 cubed, so it really didn't make much sense to write them each down individually. Plus, it's a very short equation, so it was really easy for me to type it in. So each one of these is representing c cubed over 2, if you notice, every single one. I did put a parentheses around all of these when I typed it in the calculator, but once you press enter, it gets rid of them. So we started at 2, and we went all the way up and stopped at 8. I press enter, and there's my answer. So my answer here is 647.5. All right, example 4. Expand each series. So we've got our equation right here, 4 minus p squared. So 4 minus p you do first, and then you square it. Now the difference here is there's a 3 in front of this. So this is saying 3 times sigma 4 to 8 of 4 minus p squared. So that means we're going to multiply 3 times whatever the answer is that we get here. So we're going to do 4 minus p squared. 4 minus, I'm making a blank for p squared. 4 minus p squared. 4 minus p squared. Let's see if I did enough. So we're supposed to start. We're not starting at 1 this time. Remember, the bottom number in the sigma is what we're starting with, and we're stopping at 8. So we're going to do it when p is 4, 5, 6, 7. I need to do it one more time, and 8. Let's find out what each one of these is. So 4 minus 4 is 0. So 0 squared is 0. 4 minus 5 is negative 1. Negative 1 squared is 1. 4 minus 6 is negative 2. Negative 2 squared is 4. 4 minus 7 is negative 3. Negative 3 squared is positive 9. And then 4 minus 8 is negative 4. Negative 4 squared is 16. So what we're going to do now is add all of these together. Remember, you add all your sums together. So 0 plus 1 plus 4 plus 9 plus 16 is equal to 30. Normally, we would say that's our answer. But what we just found was what this guy equals. This right here. We found that this is equal to 30. So now it really says 3 times 30. So what we have to do is multiply 3 times the answer. And then 3 times 30 is 90. 90 is our answer for example 4. All right, last but not least, example 5. Example 5, I'm asking you to expand each series and evaluate again. So this one is very similar. There's a 1/2 in front, and we're just going to have to evaluate this guy first. So this one is saying x squared minus 5. Notice the squared was only attached to the x this time. It's not on the outside. Okay, so we're going to start when x is 2, and we're going to end when x is 4. So we have x squared minus 5. X squared minus 5. X squared minus 5. X squared minus 5. Start when x is 2, 3, and 4, and that's it actually. So this is 2 squared is 4. 4 minus 5 is negative 1. 3 squared is 9. 9 minus 5 is 4. 4 squared is 16. 16 minus 5 is 11. Now what we have to do is add these all together. Negative 1 plus 4 plus 11 is equal to 14. And remember, we're not done because what we just found was this. This is equal to 14. We still have to multiply 1/2 times 14. We still have to multiply this guy times 14. So what is 1/2 times 14? That's like saying 14 divided by 2, or you can just use your calculator. And 1/2 times 14 is equal to 7. And that is the example for our last example, example 5. And that is it for today's lesson. Tomorrow you will not have a lesson. Tomorrow you will have this assignment to do. It's 8 questions. Remember, you should just be able to use your notes to be able to complete this lesson. And I will see you again on Thursday.